Hi guys, welcome to another digital math lesson made just for you guys for Pre-Algebra Chapter 11, continuing on to the next lesson, 11.3. We're going to be talking about distance and midpoint formulas. Distance refers to the numerical length of something, and the midpoint is going to be, well, exactly what it sounds like, the middle point of a line. And we're going to be focusing on two formulas that talk about how to find the midpoint formulas. If you can evaluate, if you can plug in numbers, you can do this lesson just fine. So first things first, let's go ahead and look at the distance formula. Now right here, this is a very important formula. This is one of two key formulas that we'll be using throughout this lesson. And to find the distance of any line, alright, that can be written as 2 points, you would use this equation. So I'm going to go ahead and circle this guy. Let's go ahead and circle it a few more. So let's go ahead and circle this guy. Yeah, that's good enough. Circle it another time because it's really important. Alright, so we're going to be using this formula. So we're going to use this. Now, if I had a line like this one, and let's say that the endpoints on this were on a graph, and we call this point at 0, 0, and let's call this point, and let's just make up a point, 5, 2. What would the distance of this line be? Well, what we would do is we'd go ahead and pick which point is going to be 1 and 2. It doesn't really matter, so let's go ahead and call this x1, y1. Remember, every ordered pair has an x and y, all right? And we'll call this guy x2, y2. And all we're going to do is plug into our equation. Remember, whenever we plug into equations, I prefer that you guys just start with everything blank and then fill in the numbers as you go along, following the order of operations and just working our way through it. So x2 minus x1, we have x2 minus x1, so this is going to be 5 minus 0, plus y2 minus, or y squared, minus y2 minus y1 squared, is just in different color. So y2 is 2, and 0, we have 2 and 0. I will go ahead and try to settle this parentheses first. 5 minus 0 is going to be 5. So this is 5 squared plus 2 minus 0 is going to be 2 squared, which is going to give us 5 times 5 is 25. 2 times 2 is 20, or is 4. And this would give us a square root of 29. Okay, now this is not a perfect square. I just kind of made these numbers up and got numbers that aren't going to be perfect, but you might get homework questions that ask you to round to the nearest tenth. So with a calculator, I'm going to go ahead and plug in the square root of 29 is going to be 5.38, which is going to round to about 5.4, rounded to the nearest tenth. So if you can plug in numbers, if you can take the values given for the ordered pairs and plug them in, then we have a really good shot at doing really well on this homework assignment. Now let's go ahead and look at example number 1 using the distance formula. Find the distance between these 2 points. When point A is 6 and 3 and point B is 1, 9. We're just going to go ahead and use this equation. All right. So first off, we have to figure out which one's going to be x1, which is x2, or x1, y1, x2, y2. I'm going to go ahead and say that this is going to be x1, y1. And let's go ahead and make this guy x2, y2. Now, it doesn't matter which order, but for me, a very particular person who likes to keep things in relative order, the first point that I usually see, I make x1, y1, the second point, x2, y2. So now I'm going to go ahead and rewrite my equation. So the distance between these 2 points is going to be the square root of blank minus blank squared plus blank minus blank squared. We're just going to go ahead and plug in these values. Now we're going to go ahead and say x2 minus y2. So I have, or x2 minus y1, x1 is, my bad. x2 minus x1 is going to be 1 minus, it looks like 6. I just plugged in these values. squared plus y2 minus y1 is going to be 9 minus 3. Now, order of operations, we still have to follow it, so let's go ahead and simplify this the best that we can. This is the square root of 1 minus 6 is the same thing as negative 5 squared, plus 9 minus 3 is the same thing as 6 squared. Now notice we have negative 5 squared, but because it is in the square root sign, or in the square, we can go ahead and multiply negative 5 times negative 5 is positive 25, plus 6 times 6 is 36. I go ahead and add these together, and I get this is equal to the square root of 61. Now, 61 is not a perfect square, so if I take a calculator around to the nearest tenth, I'm going to go ahead and get 7.8. So this distance is approximately 7.8 units. Let's go ahead and do one more example. I'm going to opt to do example B because it looks a little bit more complicated seeing that it has a negative sign. A is pretty much the same thing you would normally see, so I mean they work the same way. I'm going to go ahead and choose to do B. Alright, so first thing we have to do is you have to designate which one's going to be the point 1 and point 2. This is the first one I see, so I'm going to call this x1, y1, and we'll call this guy x2, y2. Alright, so we can go ahead and just plug this into our formula. Our formula was d is equal to the square root of blank minus blank squared plus blank minus blank squared. Alright, so we're just going to plug in our values. It looks like we have x2 minus x1. So x2 is 1 minus 10. Alright, squared plus, and then we have our y2 and y1 is going to be 0 minus negative 3. Alright, cool? Cool. Now we're going to go ahead and simplify the best that we can using our order of operations. 1 minus 10 is negative 9. Alright, we're going to square that because the formula asks us to. Plus, and we have two negative signs combined to make a positive sign, so 0 plus 3 is the same thing as 3 squared. Cool? Cool. Negative 9 times negative 9 is positive 81, plus 3 times 3 is 9, so this is the same thing as the square root of 90. Now 90 is not a perfect square. We're just going to round to the nearest tenth in this case. So the square root of 90 is in fact 9.5. So this whole thing is about 9.5. Makes sense to me. Alright, so let's go ahead and look at example number 2. And we want to find the area and perimeter of this shape. Now, I can identify this shape to be a rectangle, noting that by definition a rectangle is going to have 4 sides. Alright, that's going to have 2 pairs of parallel sides. And in this case, this side is parallel to this side, and this side is parallel to that side. In this case, the parallel sides are congruent, meaning that side AB, the length for side AB is the same as the length of side CD. Alright, so if I can find this side length and this side length, I can help potentially find the area and perimeter, but I would also need the other side length. So here's what we're going to do. In order to find the area and perimeter, I need to go ahead and find these side lengths. What I'm going to do is I'm going to use the distance formula to figure out the distance from side A, from point A to point B. So here I have a formula set up to find the distance for side AB. And I'm just going to go ahead and plug in my x1, y1, x2, y2. So in this case, I'm going to have x2 is 5 minus x1 is 1 squared plus, we're going to go ahead and do 5 minus 8. In this case, I'm going to have 4 squared plus negative 3 squared is going to give me 4 times 4 is 16, and negative 3 times negative 3 is 9. Notice this is always going to be positive. Whenever you have a square, it's always going to be positive because you're multiplying two negative numbers together. This gives us the square root of 25, so this has a distance of 5. I now know that this side length is 5, and because this side length is congruent to this side length is also 5. So I don't have to find the distance formula use the distance formula for all 4 sides. I only need to use it twice. In this case, if I use it on this side, I also get this side for free. So consider that a bargain. Now, we need to go ahead and find the side for, let's say, BC. If I can find the distance formula for BC, then I'll be in a really good shape to find, all the information that I need. All right, so I'm going to go ahead and set this up the way I'm supposed to. Don't forget the squares. All right, cool. I plug in my numbers. Let's go ahead and say if this is, actually we'll just say this is the new x1, y1. All right, cool. I plug in my values and I get 5 minus negative 1. And then I get 5 minus negative 3. All right, I've used my order of operations to simplify, and this gives me 5 plus 1 is 6 squared. 2 negative signs make a plus sign, and this becomes 5 minus negative 3 is going to be 8 squared, which will give me the square root of 36 plus 64, which is going to give me the square root of 100, which is just going to be 10. So I now know that this side length is 10 and this side length is 10. How do I find the area? Well, the area is just going to be base times height, which is 5 times 10. I only need 2 numbers, and I get 50 units squared. Okay? And how do I find the perimeter? Perimeter would just be adding them all together, or 2 times length plus 2 times the width is going to be 2 times 10 plus 2 times 5. Should have done this in different color to avoid confusion with all of this stuff. All right, so this is going to give us a perimeter of 20, about 30 units. Now for standards check number 2, we're not going to do this one together. I am just going to make a few helpful hints for you. Notice that it's a different shape, that this is a shape called a triangle. So that means you're going to have 3 sides to find. None of them look like they are congruent, so you should probably find all 3 side lengths just in case. And also remember, the perimeter will just be all the side lengths added together, and the area is going to be base times height divided by 2. How do I know which one is the base and which one is the height? Well, it doesn't matter which one's which as long as they are touching the right angle. So this could be the base and this could be the height. All right, the hypotenuse is never the height. All right, the very last formula that we're going to be using is a formula called the midpoint formula. And here it is. Let's go ahead and circle this. All right. So this is our midpoint formula. It looks very similar, but notice we're going to be finding a midpoint, which means if we have a distance as the total distance, the midpoint is the point right between the 2 lines. Now notice this makes an ordered pair where it gives you a new x and a new y as an ordered pair. All right, well, let's look at one example to try to see how this works, but we're just going to be plugging in x1, y1, and x2, y2 into our equation. All right, example number 3 is asking us, what are the coordinates of the midpoint from line GH? Now, the coordinates means we're going to find an x and y, an ordered pair. I went ahead and rewrote the formula for us, so we're going to use this. We're just going to plug in our x1, y1, x2, y2 into this equation. So I go ahead and just plug in numbers. I need my x coordinates. My x coordinates are -3 and 7, and my y coordinates are 2 and -2. So if I go ahead and plug these in, I get 4 over 2 and 0 over 2, which simplify to be 2 and 0. And that's the midpoint. If I look here, the midpoint is actually 2, 0, right in the middle. So for problems like this, you're going to be plugging them in directly and using the midpoint formula. All right, sounds good. All right, so that concludes our lesson. Here are the 2 important equations that we had to use this lesson. Make sure you copy these things down in your notes. Make sure that you guys are taking notes in general and also keeping your work in your notebooks. All right, all work for your homework should be done in your notebook. All right, see you later. Peace.